Hello, my name is Nigel Bowden. I'd like to welcome you to episode 17 of the Wi-Fi for Beginners podcast. This is a series of podcasts discussing the fundamentals of wireless LAN networking. In each episode, we'll take a look at a different aspect of Wi-Fi to build your understanding and knowledge of wireless LAN networks. Each episode is accompanied by a set of slides describing the topics covered in that episode. Although you don't need to review the slides while listening to the podcast, they may be useful for helping you review some of the material that we discuss and provide some visual aids to more fully understand some of the concepts and equipment described in the podcast. All recordings and supporting materials can be found at my website, which is wififorbeginners.com. The podcast series is broken down into a number of modules, with each module covering a major topic within wireless LAN networking. We're currently on module number 5 of the podcast series. We started this back in episode number 14, so you might like to go back and review episodes number 14, 15 and 16 to get up to speed with our current topic, which is Wireless Lan Clients. This is a fairly large topic. We've spent quite a bit of time talking about it, and we've still got another episode or two to complete before we finish our discussions about that. So today we'll actually be continuing our discussions about Wireless Lan Clients. Before we get into any new material, I'm just going to quickly recap the topics we covered in the last episode, which is episode number 16. If you're following along with the slide deck, we actually covered slides number 31 through to 34 in the last episode, and I'm just going to run through their content very quickly before we continue with our discussion for today. We began by taking a look at a few factors which can affect the connection speed that a client might achieve. We considered things such as the quality of the RF link between the client and the access point. Things like signal level, errors experienced, and noise can certainly play a part in that. We had a look at the PHY capabilities of a client, which are very important. Things like the band support of the wireless LAN client, the number of streams and antennas that it's got, the channel width that it can support, and the 802.11 amendments which a client can support. We then took a look at the concepts of SISO and MIMO. Back in the days of legacy 802.11 amendments, things such as 802.11a, 802.11g, we only had the concept of SISO, single input, single output, and this is where we had a single stream of RF data traveling between a wireless LAN client and an access point. And then with the arrival of 802.11n, we had MIMO technology, which is multiple input, multiple output, where we can have multiple RF data streams between a wireless LAN client and wireless access points, giving us a significant uplift in the data rates achievable between a wireless LAN client and access point. We also discussed the concept of channel bonding. Again, back in the legacy days of 802.11a, 802.11g, we only had a single 20 megahertz channel in use between a wireless LAN client and access point. With the arrival of 802.11n, we had the concept of channel bonding, which actually bonds together two 20 megahertz channels into a 40 megahertz channel, which gives us a doubling of throughput for our connection between client and wireless access point. If we combine both MIMO and channel bonding technology, we can achieve some very significant uplifts in connection speeds compared to the legacy 802.11a and g amendments. We typically look at increasing speeds from legacy rates of around about 54 megabits per second up to 300 or even 450 megabits per second by the adoption of these technologies that were introduced with the 802.11n amendment. And with the introduction of 802.11ac, we can extend these speeds even further, achieving Wi-Fi gigabit speeds. And we ended our discussion by underlining the fact that the speeds we will achieve with a wireless LAN client are not just a function of the wireless LAN client itself, but also of the wireless LAN infrastructure that it connects to. In order to be able to support 802.11ac speeds, for instance, both the wireless LAN access point and the wireless LAN client itself must both support the 802.11ac amendment. And also we need to bear in mind that the speeds achieved are also a function of the configuration of the wireless LAN infrastructure itself. Just because a wireless LAN infrastructure has the capabilities to support 20, 40 and 80 megahertz channels and maybe up to 3 streams, it doesn't mean that the wireless LAN infrastructure itself will be configured to support all of those, and perhaps a wireless LAN client can't support all of those particular modes of operation. So it's very much a case of understanding whether we have parity in capabilities between our wireless LAN clients and our wireless LAN infrastructure. So now we'll continue our discussion about Wireless Lan clients. We're on slide number 35 if you're following along with the slide deck. And now we're going to be talking about some of the characteristics and requirements of clients when we're talking about Wireless Lan networks. Certainly these days we have a huge variety of client types we might connect up to a Wireless Lan network, and they've all got varying capabilities and requirements. And it's really important that we understand both capabilities and the requirements of a client so that we can design our Wireless Lan network to accommodate their requirements and to understand the load and the demands that they may place onto our Wireless Lan infrastructure so we can design to anticipate that. And when we're thinking about Wireless Lan clients, there are a number of typical factors we can think about which will affect the characteristics of each particular client. If we first of all think about the physical size of a Wireless Lan client, that's certainly going to affect things like the size of antenna we can actually fit into the chassis or case of a Wireless Lan client, and that's certainly going to affect the performance as it will affect things such as the antenna gain. We can also think about things such as the power supply, which is typically a battery in a mobile device these days, and that's going to affect things like the transmit power that we can supply to the device's RF circuitry and hence the range that we might achieve with that Wireless Lan client. Our power budget also affects things such as the number of streams that the device can support. This actually has an impact on our power budget. More streams requires more power, so this is obviously more difficult to supply in smaller devices which have got limited power capabilities. Another factor which influences the characteristics of a Wireless Lan client is the radio components that we find in that client. Each client will have some sort of RF chipset or a wireless NIC card, a network interface card, and depending on the chipset or the NIC card that we're using, this will impact the number of chains that can be supported by the client and the level of 802.11 support that the client has got. Also the radio types that we've got in the client, whether we've got a 2.4 gigahertz or 5 gigahertz radio, or maybe both in the client, affects which bands we can use, and again that has some direct input into the various features and 802.11 support levels that we can achieve. The number of antennas is also very important as well. To use multiple streams we will need multiple antennas, and whether or not we can actually use a single stream or multiple streams is dependent on a number of factors, including the chipset that we're using, the RF chipset. This will determine the number of chains which are available. Number of antennas, as I've already said, will feed into the number of streams we can support, and also the manufacturer implementation of the RF circuitry. Just because we've got a chipset which supports multiple chains doesn't mean that the manufacturer will actually implement all of those chains in the implementation of the Wireless Lan client. We've talked a number of times there about a chain. I just thought I'd put a little bit of detail around that. Radio chains were introduced into Wireless Lan clients with the advent of the 802.11n amendment, and chains are the thing that actually gives us the capability to use multiple RF streams between clients and access points. And a wireless chain is actually digital signal processing circuitry that splits and combines signals into multiple streams, which allows us to do this over a single radio. So we still only have a single radio in our client or our access point, but the signals can be split, and via the use of multiple antennas we can actually have multiple parallel streams of RF data flowing at the same time. So that gives us some idea what we mean by a chain. We're not talking about multiple radios, it's actually some signal processing circuitry that allows us to use one radio and split our signal into multiple streams of data. But probably the most important characteristic of all when considering Wireless Lan clients is the level of 802.11 amendment support that it provides. This can give us things such as power save support, which is very important for mobile devices. It influences things like the speed of access that a client can achieve. Obviously, higher speeds we've previously discussed give us a higher capacity and higher efficiency for our Wireless Lan networks, and lower speed clients actually negatively impact other clients on the same AP cell. It also gives us things such as roaming decision support, and better roaming decisions are certainly going to help with our overall network capacity and efficiency. And it gives us things such as QoS support, quality of service, very, very important when we're starting to talk about putting voice and video across our Wireless Lan network. So ensuring that we can support the required 802.11 amendments is key, especially when we're thinking about the design of our Wireless Lan network. So these factors we've talked about determine the characteristics and the requirements of our clients, and it boils down to two questions really when we're thinking about a wireless LAN design. The first question is, can we meet the requirements of our client? Can the wireless network we're providing provide the required features for the clients that we're supporting? For example, if we've got a network of 802.11n access points, we're never going to be able to provide the high speeds that an 802.11ac client is capable of achieving. So we have to ensure that our wireless LAN infrastructure has the feature set to meet the requirements of our wireless LAN clients. And this is generally achieved by ensuring we have at least parity of 802.11 amendment support between wireless LAN clients and wireless LAN infrastructure devices. Conversely, we also need to ensure that the wireless LAN clients we're using on a wireless LAN infrastructure can support the features that we're providing on that Wi-Fi network. We need to ensure that the clients have the characteristics we need to provide those features. For instance, if we're using a wireless LAN infrastructure which is going to support 802.11r fast secure roaming, because perhaps we've got a voice application on there, we need to ensure we've got fast roaming between access points. Do our clients actually support this? It's no good actually providing this feature on our wireless LAN infrastructure only to find that our wireless LAN clients don't support it, and we can't actually get seamless roaming for voice calls across our wireless LAN infrastructure. So we need to remember that the bottom line here is, without this feature parity between clients and the wireless LAN infrastructure in terms of the 802.11 amendment support, the performance of the wireless LAN is always going to be restricted to the lowest common denominator of feature support on either the wireless LAN client or the wireless LAN infrastructure. So, as we've discussed, it's very important to understand the capabilities of any wireless LAN clients you're going to be deploying on your wireless LAN network. And we're just going to take a look at a few sources of information where you can actually dig a little bit deeper into the technical capabilities of your wireless LAN client. I've got a bullet point list of a few different sources you might like to check out. I've also done an accompanying blog article for this particular slide. We're on slide 39 of the slide deck. And if you get along to my website, which is wififorbeginners.com, and have a look at the show notes for this particular episode, you'll be able to find a link to the blog article. So the first place you might want to start is actually the manufacturer's documentation for the particular client that you're using. Now, the levels of documentation support with various manufacturers is going to vary very much from manufacturer to manufacturer. If you've got some very well-known manufacturers' products, then it's more likely to be the case that you're going to have good support for them. But if you've got some fairly cheap and cheerful wireless LAN clients, you may well struggle to find detailed technical information about that particular client. So first port of call is probably have a look at the manufacturer's website or any documentation you get supplied with the client. But generally, in many cases, it's pretty lacking and doesn't give us the depth of information that we need. A very good place to check for detailed technical information about wireless LAN clients is the Wi-Fi Alliance website. They've actually got the Wi-Fi Alliance product finder, and the web address for that is www.y-fi.org/product-finder. You can find that on the slide deck if you didn't catch that URL. But there they list all of the certificates for all of the devices which they've certified for operation for different 802.11 amendments. And you can go in there, just type in a manufacturer and a device type, and if the device has been certified by the Wi-Fi Alliance, you can actually look at its certificate, and on there you'll be able to find the 802.11 amendment support that it's got, and it gives you details such as the RF band supported, number of streams, channel width support, things like that. So it's an excellent source if you can find your product listed on there. Not all products are listed because not all products are certified by the Wi-Fi Alliance, unfortunately, but it's worth checking there first for some really first-class, easy-to-access information. If you don't have any luck with the Wi-Fi Alliance product finder, it's certainly worth getting along to the FCC website. Even if you're outside of the USA, check out the FCC ID database, and you can find that at fccid.io. That's the web address, fccid.io. Again, that's on the slides of the podcast if you missed that. But if you get along there, you can look at all of the test data that the FCC holds for all of the different wireless clients that it tests. Anything that's going to be used from an RF perspective in the US has to be subject to FCC testing. So you can get there, type in the FCC ID number from the wireless client that you've got. Generally, it will be inside the case, or maybe stamped on the outside of the device, or maybe in the user documentation. But somewhere you'll have an FCC ID. Simply type that number in, and you'll get access to a whole raft of RF reports and supporting documentation. If you dig around in there a little bit, you can certainly find out some very interesting technical information, and certainly all of the RF related information that you need, including 802.11 amendment support. Another place you could actually find interesting and useful information about your wireless LAN client is to actually associate it to an access point on your network, maybe set up a test SSID. And if you've got a wireless LAN controller or maybe a wireless management system on your wireless network, you can usually have a look at some of the information that it reports about clients which are connected. You can find your particular client, and generally somewhere in there you'll find information about your wireless LAN client. The information you get will vary from controller to controller and management system to management system, but you'll generally get some sort of information about its capabilities, which you can use as a few clues to understand the capabilities of your particular wireless client. And don't be scared to dig around on the CLI of your controller as well to get some more detailed information. Another good way of getting some fine-grained technical details about your wireless LAN client is if you have access to a wireless packet analyzer. Maybe you've got something like Wireshark if you're using free tools, and you can get things like Air Magnet Analyzer and OmniPeak, which can also be used for packet analysis. And if you can actually capture a association request packet from your client, you can look in there and dig into the various capabilities fields, and you can see things like the number of streams supported, channel width support, and all those sorts of information that you need to try and understand the capabilities and the speed that your particular client can achieve. And finally, if all of these fail, then you've always got Google. You can always try Googling something to see if you can find any more information about your clients. Generally, in my experience, you don't find particularly good information that way, and certainly one of the previous methods that I've described is certainly far more productive in terms of finding some good quality technical information about your clients. So again, just like to refer you to the slide deck. Go to slide number 39 and you can see all of the URLs for those various tools that I've talked about, and have a look around to see if you can find information about your wireless LAN client. So we'll round off our discussion of wireless LAN client characteristics and requirements by taking a look at 4 typical wireless LAN client types that you're likely to meet if you do any work with wireless LANs in general, and maybe if you support a wireless LAN on a day-to-day basis, you'll probably be very familiar with these. And we'll just have a look at their typical characteristics just to give you a flavour of how the various factors that we've spoken about affect the way that these clients actually behave. So first one we're going to take a look at is the good old laptop, and this was the original Wi-Fi client in many organisations going back quite a few years. Because of its inherent power requirements, it generally has very good battery life, has a good power supply, and this is because it's supporting many other devices beyond just the Wi-Fi NIC. It's got things like the screen, it's got mechanical discs potentially, it's got fans, high power processors, that sort of thing. So it's got very good power supply generally, which means it can also give us very good performance from a wireless LAN Wi-Fi NIC performance. And they generally have a very high spec wireless NICs, very good transmit power levels available. Very often we'll have multiple antennas, and these are often housed in the screen, so you can have 2, maybe 3 antennas housed in the casing of the laptop itself. And so this allows us to use multi-stream support, which means we can obviously achieve some very good over-the-air speeds. The 802.11 amendment supported by the laptop depends on the chipset that's installed, installed. Hopefully in today's modern laptops we tend to get 5 gigahertz support, maybe 802.11n, 802.11ac, but even in some budget laptops which are still available today, we still get chipsets and NICs installed which only support 2.4 gigahertz, which obviously limits the 802.11 amendments that we can support. We obviously got no 802.11ac support. So if you're buying laptops, always check that you've got a half decent wireless NIC installed in the laptop that you're buying. And generally these are probably the highest performing of all clients because of their power they've got available, because of the number of antennas, and they've got high powered chipsets that we can use. But they are actually shrinking in terms of the total number of clients on Wireless LAN. We're getting more and more mobile devices, things like smartphones and tablets, which are starting to become more and more popular. So they are sort of shrinking in terms of their population over time on wireless LANs generally. The next type of client we're going to be talking about is tablets. You're probably very familiar with these, things like your iPads. The main constraints of this client type is the battery life, which is related to the size of the device itself very often, and also the antenna size is again limited because of the case size of the tablet. We can only get very small antennas in there. We've got very small space to actually accommodate antennas, and the Wi-Fi capabilities are heavily constrained by this combination of small antenna sizes, very limited battery life. It limits the amount of transmit power that we can apply to the radio chipsets for the tablet. The radio chipset that's installed in a tablet typically tends to be a one-chain device that allows us to use one stream. We are getting more and more two-stream devices that are starting to pop up now, but there is a power penalty for that. The more streams that we have, the more drain we have on the battery. But yeah, mainly one stream, some two-stream devices that are starting to pop up now. Again, talking about the antenna, because of the small antenna size that we've got, because of the lack of space in the tablet form factor, because we've got a small antenna, we've got very low antenna gains, and this really does give us much lower range and low performance compared to something like a laptop, which has got a good physical space to accommodate multiple antennas. So we're very limited on the antenna size, antenna gain, which affects the distance over which a tablet can receive signals, and also the distance over which it can transmit back to an access point. So it gives us a much smaller cell of operation to operate over compared to a wireless laptop typically. Smartphones, the next client we're going to have a look at, they're very, very similar to tablets. Again, constrained by their battery life, by the antenna size, which is all related to the physical size of the smartphone itself. Again, we're very limited in the transmit power that we can use for our RF circuitry. We are almost exclusively limited to one spatial stream devices. There's only one spatial stream which is used between these clients and the wireless access point. So this gives us significant limitations in terms of the speeds that we can achieve over the air because we're limited to one chain and we only have one spatial stream. And again, the antenna size, because of the small size of it, we've got very low antenna gain. In fact, it's even worse than tablets. So we've got a very low range and much lower performance than both tablets and laptops. So we're going to receive a signal over a much smaller area, and we're also going to be able to transmit back to the AP over a much smaller area. So our effective cell size for smartphones is a lot lower, a lot smaller in terms of radius compared to the other types of devices. And the last client we're going to take a look at is far less popular generally, far less likely to see it unless you're in specialised situations, but that's a hand scanner or some type of a barcode scanner, very popular in the retail sector and warehousing, logistics type applications, but these have been around like laptops for a good many years in Wi-Fi networking. They're very similar in some ways to wireless laptops. They've got a very good battery supply because they have to be used all day by operatives walking around something like a warehouse. They're generally charged up overnight, so they've got very good transmit power available to their RF circuitry. This makes them very unusual compared to the other devices that we considered. All of the others, they tend to have fairly high data requirements depending on the applications being used, but we only usually have to transfer very small amounts of data using hand scanners. It's usually just stock updates and stock checks, things like that, very small amounts of data. And because we we have much lower data throughput requirements, we can use lower connection speeds over a further distance, and because we can use lower over-the-air connection speeds, they can be used over much wider distances than any of the other devices we've discussed. We can travel a long way from a wireless access point, and we can go down to very low connection speeds because of the low signal levels that we've got, but these will still provide sufficient data throughput to support the hand scanning application. So we've taken a look at a very small subset of wireless client device types. These are a fairly representative sample that you'll find in many enterprise environments, but there are many other types of client which you may come across in your work with wireless LAN infrastructures. But the same set of considerations still apply across all clients. We still need to understand their standard support, the 802.11 amendment support that they have. We need to understand their radio capabilities, which bands they're actually able to operate on. Their power capabilities are a consideration because this feeds into things like the number of streams that they can support, the throughput requirements of a client. This relates to the applications that they support, things like voice, video, data. They're going to be different throughput requirements depending on the application that they support. Their antenna capabilities are obviously a key factor as well. The gain and the number of antennas has a direct impact on the data rates which can be supported. And there's also things like security standard support, which we haven't actually talked about. We'll be looking at security in wireless LANs in a later episode, but the security capabilities of a client and how that maps into the security requirements of our wireless infrastructure is also a key consideration, but as I say, we'll be taking a look at that at a later date. So that pretty much wraps it up for this particular episode. Don't forget you can get along to my website, which is wififorbeginners.com, where you can find all of the supporting materials for the podcast. We've got all of the audio presentations, the slide decks, we've got some quizzes up there, and also some useful links to other Wi-Fi learning resources, which will help you with your wireless LAN studies. So just going to do a very quick review of the topics that we've covered in this particular episode. If you're following along with the slides, we started back on slide number 35, and we started by taking a look at the typical factors which affect client characteristics, which we're so interested in understanding when we need to provide for them with our wireless LAN infrastructure. We started by talking about the physical size of a client, which can affect things like the antenna size that we can achieve, and also the power supply, and obviously the power budget that we can achieve with that particular form factor. We also talked about the radio components of a client, how that affects the client characteristics. We talked about things like the chipset, the type of chipset or NIC that we use affects the number of chains, and 802.11 support that we've got. We talked about radio types, 2.4 or 5 gigahertz radio support. We also talked about the number of antennas, which directly relates to the number of streams that we can achieve with the client, and obviously that impacts the over-the-air speeds that we can achieve with the client. We then went on to talk about how important 802.11 amendment support is in understanding client characteristics, and this can give us features such as power save support, and it affects the speeds of access that we can achieve, also helps us with achieving better roaming decisions for our clients, and also gives us things like QoS support, which is vital when we're looking at voice and video over wireless LAN networks. We then went on to look at a number of methods of how we might find out the capabilities of wireless LAN clients that we're using on our Wi-Fi network. We talked about the way that we would look at manufacturer's documentation as a first stopping point. Then we'd maybe have a look at the Wi-Fi Alliance Product Finder resource, which is available from their website. We can take a look at the FCC website and have a look at their ID database. We can also collect client data from a wireless LAN controller or a management system to find out about its capabilities, and we could also potentially have a look with a wireless packet analyzer by capturing some packets over the air to understand the wireless LAN capabilities. And then finally, if all else fails, of course, we can always have a look at our good friend Google. We then took a very quick look at 4 typical wireless LAN client types and discussed their characteristics. We started off by looking at laptops, which was the good old standby original Wi-Fi client that was used by many organisations. Its characteristics are very good battery life, good power supply support because of the various components it has to support, and we tend to have high speed NICs and multiple antennas to allow us to support high over the air or wireless LAN speeds. And we still have to be a little bit careful when buying wireless LAN laptops. If we go for budget models, you still get the occasional low-performing 2.4 gigahertz NIC creeping in there, which we need to avoid at all costs. We then took a look at tablets. The main constraints of tablets are the battery life that they can achieve and their antenna size, which is directly related to the form factor of a tablet. And tablets very heavily constrained in terms of their transmit power and the number of chains, and hence the number of spatial streams that they can support, and this limits the over-the-air speeds that we can actually achieve with them. We considered smartphones, which are very similar to tablets. Again, constraints are battery life and antenna size, which is related to the form factor of a smartphone. And again, we're very limited in terms of transmit power that we can achieve with a smartphone, and we tend to be limited to just one chain and obviously much lower over-the-air speeds as a result of this. We then took a look at a hand scanner, and we talked about its characteristics, which are very much suited to warehousing and large retail type environments where it's used. It's got a good sized battery on it. It only has low data requirements in terms of connection speeds and data throughput. So this enables us to travel over very long distances throughout a warehousing type facility, and we can just achieve low connection speeds, and that's not a problem at all for the low levels of data that we need to shift between the hand scanner and the Wireless Lan access point. And then we reminded ourselves again that when we're considering Wireless Lan clients to be used on our network, we really do need to understand the 802.11 amendments that they support, their radio capabilities, which bands they operate on, their power capabilities, their throughput requirements in terms of the applications that they'll be supporting, that's voice, video, data, their antenna capabilities, and finally we also need to understand the level of security that they will support and whether this actually complies with the security requirements of our Wireless Lan infrastructure. Well, that pretty much wraps it up for this particular podcast. I hope that the information in this podcast has been of use to you. Don't forget that you can get along to my website, which is wififorbeginners.com, to access all of the supporting material that accompanies the podcast. I'd also like to invite you to sign up to my mail list. I put out a monthly newsletter which has got a lot of additional information to support the podcast, give you some interesting news and a few interesting pieces of information to go and have a look at to help you with your ongoing Wireless Lan study. So get along to the website. You can see there's a little sign up form there on the right hand side of each web page, and really like to have you join the mail list and drop something in your inbox on a monthly basis and to help you along with your Wireless Lan studies. Thanks very much for joining me, and I look forward to joining you again soon on the next edition of the Wi-Fi for Beginners podcast.